Hello, hello. Are we live? Okay, welcome back to the Advent of Cintran 2024. This is day 15. It's December 14th, but it's about to be December 15th in 2 minutes. So, the drop timer is counting down. My download script ready to go. And I'm ready to edit my template as soon as my download script creates my template. The Twitch bot is running. Let's double check on the Twitch bot. That's working. OBS capturing the bot. Okay. Now we wait. 1 more minute. I redid day 11. I made a dictionary. I don't know if I have time to talk about all of this in 1 minute, but I made a branch in Cintran where I added pass by reference as a feature, because to do a dictionary the right way, you basically need pass by reference. Either that or you waste a lot of time copying in and copying out. Every time you modify a dictionary, you have to copy twice. Every time you get something from a dictionary, you have to copy it in. Or if you have pass by reference, you don't have to copy. You just make a reference, and that's fast and efficient. Without that, I could work with a dictionary as a global variable. I'll review this code later if I have time, if this puzzle doesn't take forever. But global variables are bad because then you can really only have one dictionary unless you do some really terrible stuff. So that's on a branch, but it's not in production. I'll think about using it if I need to use a dictionary for anything. But let's see what day 15 is here. Here we go. Download. Edit. Another grid. No, we have a grid and then something else. Directions. Lots of directions. So we have like a 50 by 50 grid, and then like 20 lines of directions. Okay. There's an at, there are O's and hashes. Hashes are along the walls. Okay, so I guess we have to follow the directions. Let me save this test input. Okay, let me get rid of my new lines. Okay. How many lines of directions do I have? 10 lines of directions and a 10 by 10 grid. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I got all of that. What are we doing? Lanternfish. Lost control of the robot. More robots. Boxes. I think the at is the robot. At the robot? Okay, yeah, the robot is the at. There are boxes, and the boxes can also move, I guess. We'll attempt to push. But the boxes can't move past a wall. Okay. And the directions are what you would expect. Multiple lines. Okay, ignore the new lines. Can't move left. Can't move left because there's a wall right there. Move up, can't move up again. Move right, and then we do move right, and then we push this box. Then we move right again, and we push 2 boxes. And if you try to move right again, you can't move because the boxes are all stacked up against the wall. Okay, I think I get that. Yeah, we're gonna have some scanning in here. Okay, and then we have to do some checksum on the box positions at the end. All right, I think I get this. That doesn't sound too bad. The keeping track of a stack of boxes, that might be a little tedious, but I think we can do it. You only have to keep track of 1 line of boxes in the worst case. Okay, so I should be able to run, and I don't think I'm going to need a dictionary for this. I don't know what that tab completion was. So I'm not going to have to use any funny branches. Okay, so we're going to save the grid, then parse a new line, and then save the input. So unfortunately, I think a while loop is the best way to do that. Let's just make them both 0. So I don't want to go till EOF. So that should read just the grid. Okay, there we go. And then I'm going to want to read the grid next, and that is until EOF. Okay, so NY is going to get incremented there. And then actually, NX is the length of the first line. Let's see if I get those dimensions. Should be 10 by 10, and I want to cast the length down. 10 by 10, and where is, I closed the file. There's the input. Okay. And then we're going to have the instructions start out as an empty string, and then just concatenate all of the instructions onto this thing. I want to load characters too. I think I want to debug the instructions first. Okay, now we have 1 big line, 1 big string, single line of instructions. It's my grid of characters. I'm going to keep them as characters. And then shit, I have to do 2 passes on the characters. Could have done this with a for loop, actually. I needed the while loop to count, but then I need to make a second pass. So close file, F equals open file name. You have to read 1 line. Need a semicolon there. What happened there? Okay. Right, I can't save these yet. You have to make 2 passes, one to count, and then another to load it. Don't redeclare that. Oh my god. Okay, reuse that variable. Something is bad. What? Did I read? F equals open. String equals read line. Okay, what happened? Close? Did I close correctly? Close F. Why am I struggling with this? I've done this before. Right, that's dangerous. There we go. Okay. Finally. Didn't waste too much time on that. We've been at this for like 9 minutes. Okay, now we can solve the puzzle. We can start to solve it. So, how about instructions? Insters. So, for I in 0 len instructions, okay, we can iterate through instructions. Now we have to move the robot. Yeah, let's figure out where the robot is. A, because it's the @ symbol. Okay, 4, 4. 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. Looks right. Yeah, and I'm not going to map everything else, anything else. And in fact, I think I want to reset that because the robot's going to move and we want to pretend it's an empty space otherwise. So chars ax ay equals dot. Dots are empty, uppercase O's are boxes. Then we have instructions. Okay, so where have I done this? Let me steal something from day 12. so we have that. So that's negative x left, right, up. Even though it's negative, y positive is down. So that's why those are in that order. And then let's encode that in a string too. In the same order, left, then right, same order as this array. Left, right, up, and down. Okay. So, we're gonna scan instructions for this. That should be 0 through 3. Okay, so those encode our directions by scanning for a position of this inside this string. And then we can just index into that array with the ID direction identifier. And then we can do that. And then yeah, now the hard part. We have to move the robot and see if it runs into anything. Back up the initial position, and then we're going to move it and see if any collisions happen. And if collisions happen, we're just going to reset everything. Yeah, so I want a whole backup of the cares array too. Okay. So we're going to move, and if any collisions happen, we're going to reset the robot X and Y, and then we're going to reset the cares array too, because we're going to move boxes as well. Yeah. So X plus equals D0 and Y plus equals D1. That moves the robot. And then move boxes if necessary. Okay, so I don't know how I'm going to break out of this. We'll figure it out once we have a little more code. These are the O positions. Potentially. There might not be a box here, and then we don't have to do anything. So that's going to be the break condition. So if cares OX OY is a free space, dots are free spaces. So if we have a free space, then we can break because we're done resolving collisions. And then collide is still false. Yeah, that's good. Now, we could have robots colliding with boxes. That's resolvable. If we have a robot colliding with a wall or a box colliding with a wall, then we reset everything, and that's an unresolvable collision. So, if we hit a wall, we're also going to break. And then this is an unresolvable collision. And actually, we have to reset things. I don't think I need the Boolean. Reset x, y, chars to the not. Okay, but what if we don't hit any of those cases? What if we're on a box? I think it's an uppercase O. It is. Okay, so if that happens, we're going to check the position after it. So OX plus equals D naught, OY plus equals D1, and we're going to move the box. So chars, we're going to take out the box, and then we're going to put in the box. So this becomes, oh. Char not equals, initially it's going to be a free space. Yeah, the first box, really it's the robot, but I don't want to fill in a character for that. I want to make it a free space. So char not, and then chars OX, OY becomes a box, and then char not becomes a box. So then when we move the second box, instead of filling it in with a free space, we fill it in with the last box. I think that should work. And then we don't, in this condition, we don't break. We go to the next iteration and move the next box if we need to. But if we have to reset things, x is x naught, y is y naught, and chars is chars naught. So chars, I have a chars naught and a char naught. Okay. So actually, I think this can be local. Does it reallocate on every iteration? Maybe. I don't know. That runs. And then what's our score? It's like x plus 100y for each box. Or is it vice versa? Plus equals 100 times y plus x. But that's only for boxes. I think that's it. That doesn't seem right. We're expecting 2028. Did I take the wall condition into account? See what that looks like. I think I'm going to have to debug individual steps. So it looks like nothing happened. Yeah, nothing ever moved. free space we break. If we have a wall, it's unresolvable. Do we ever hit this? Okay, we're moving boxes. Why didn't this work? Did anything move? Nope. Pretty sure nothing moved. What the fuck is that? Syntactically valid. I think I should ban expression statements. Oh, yeah, we need a bounds check. Aren't there... I mean, shouldn't the walls, like, automatically create an implicit bounds overflow prevention? Okay, what overflowed? XY is 3, 4. It's the first move. Why are there so many box moves? Did I update? I updated OX and OY. Cares. What happened? It just ran away. So the first instruction is left. Okay, so we move the at to the left. Oh, I see. We're filling in the wall with an O. So you don't want to do that. So if cares OX OY not equal wall, only then do we move the box. Okay, it didn't crash. But nothing moved. So this box should move to the left. OX, Y. Why does it keep going? Oh. Do I want to check cares not? That's an infinite loop. Okay, and now this box moved to the left. That's good. So I'm going to take out this early exit, maybe remove that debug. That looks... Doesn't that look kind of correct? $10,092. Oh. Oh, I was thinking 2028, but they give you two different answers there for multiple examples. All right, I think I have this. That was a little tricky. And now, yeah, run the real input. This is gonna print a bunch of stuff. I've got a good feeling about this. Probably don't need 64 bits. All right, that's part one. What? Oh. Oh. Okay, they're only twice as wide in the left-right direction. So I was thinking I'm getting like 4 times as many cases. But I think I only need like double the number of cases. That doesn't seem too bad. Closest edge. So you only got the left bracket. All right. Yeah, I think I'm not going to be up too late tonight. It's really risking it, thinking like we're going to run into a hard problem eventually. And I don't want to start working on something difficult at midnight, but I think we have a manageable problem today. Okay, let's go back to the test input. Let's copy part 1 and make that part 2. And let me clean up the logging in part 1 and some of the dead code. Okay. That should be part 1, but less verbose. I'm not calling part 2 yet. There we go. Let's call part 2, and then that's going to log verbosely. All right. And it's just repeating part 1. So now we have to do the part 2 logic. So we're going to translate the input into something that's twice as wide. So we're gonna count and then just double that, John. So twice as big, twice as big, and then be careful about this because I have bad variable names here. So it's really like half x and half y. It's going to be y half. And then this is going to be x half. And then we have to map the input. So y doesn't change though. They're twice as wide. Twice as wide, but they're not twice as tall. Yeah, they're only doubling horizontally. They're not doubling vertically. So let me undo some of that because the y's are okay here. And this, yeah, we're not doing that. We only double x. Okay, so what are we doing here? This is going to be x half. But we already doubled that, so that has to be over 2. Or we could just loop up to the length of the string. Now, can do that. And then boxes doubled differently. I want to actually expand these into square brackets so I know which half of the box pairs up to which other half. Because when you have two boxes next to each other like this, you don't want to like accidentally think that these two brackets are matched up because they're not. They're two separate boxes. This is one box and this is one box, but these two are not. So you want to keep track of that left-right bracket pairing. And to just use the actual inputs is the best way to do that, or it's good enough. So in the default case, well, if string x, that's really xh. So if that's not a box, if it is a box, we're going to do something special. Else we're going to have a default case. So here chars x and y. It's just the input string. And then x plus 1 is the same thing. X plus 1. Okay, so hashes just become 2 hashes, dots become 2 dots. At is also a special case. We only have one robot, but I kind of already have a special case there. Okay, so dots and hashes just become doubled. Dot or hash. That's not right. Okay. See, I already filled that in. So I don't really need to do anything special here. just replace it with a dot, because that's how the rest of my logic is set up to work. You could implement it differently and keep that as an at. Okay, and then O is actually going to become the left one is a left bracket, the right one is a right bracket. So did I parse the input correctly? That's the first question before we even start worrying about the instructions. Okay, we have brackets that are paired up. The walls go all the way across. We have double walls on the sides, is that right? Okay, apparently. Looks a little weird, but that's what they say to do. Yeah, and then this at, well, that's not right. So I really need like a switch case statement in this language, because it's annoying to type this thing multiple times. Okay, now the at disappeared, and AX, AY should be eight four. I think, isn't it 4-4 for part one? Yeah, it was 4-4 and now it's 8-4. So that's good. We've doubled the X position, but not the Y position. That makes sense. Okay, now we can start pushing boxes. And we only need special logic going up and down. Going left and right, well, I kind of have to swap out my characters. So I'm not checking for O's anymore. I'm going to check for boxes. I think this logic, like char 0, oh, well, that's not exactly right. This is going to have to be char 0, I think. Going to do it like this. It looks like a mess of brackets, but trust me, that should make sense. I want to replace this one now so I don't forget later, because it's like outside of the main loop. And scoring is still the same, right? Still 100. GPS 100. Oh, no, it's just closest edge. So I think we only want to test, actually want to undo this. So you just want to test for the left bracket, I think, if I understand that scoring. Okay, now what are we doing with the box pushing? So that should be the previous character. Then we have that. And then or that. But this is really just left-right logic. Our old logic was good for moving left and right, but we're going to need special logic for moving up and down. Oh, God. Oh. No, because you could really end up moving a lot of boxes. Like, so we have two staggered boxes here. What if they just keep staggering up diagonally? And they might like expand in multiple directions. Okay, this is more complicated than I thought it was initially. Oh my God. Yeah, and I think I need a literal stack data structure of boxes. As they get collided, I want to push them onto it. And then I want to check if they have resolvable collisions. I don't know if I want to be working on this at 1 a.m. I might give up tonight and come back to it tomorrow morning. But I'm not giving up yet. Okay, and we also have walls in the middle, so that complicates things. There's not just walls at the edge. I wonder if you could have a list of boxes and just keep track of when they're blocked in a certain position, in a certain direction. Maybe that's a better way to do this than having like stacks of boxes. Yeah, I feel like that's easier. Okay. I think we have an infinite loop for part 2, but like I'm not done writing the code yet. So if you're a box and you have a wall to the right of you, then you can't move to the right. You might also have a wall above you and to the left of you, so you might have blockages in multiple directions. So if there's a wall next to you, that's easy. But what if you're a box and you're next to another box? You want to check if that box is blocked in that direction. And then this box will inherit the blockage of that box in that direction. It's not going to inherit the blockages in every direction. Like, for example, this box is blocked from moving to the right, and this box is next to that box, but they can move up. right? But imagine if there was a hash here, then this box would also be blocked from moving up. So I think I can do that logic, and then I only need to update things that get moved. And I'm not going to iterate on the input character array. I'm going to work on a list of boxes. So I think that's an easier way to do things. And every box has like a position, and it also extends one more to the right. I think I can just like hard code that data. I don't need to have like a variable width box. Okay. So let's scan grid to make a list of boxes. And we have left brackets matched with right brackets. I don't really need to translate the input if I'm going to work with a list of boxes, but it's already done. Count chars equals that. Okay, so we have 21 boxes in the test input. That looks reasonable. 1, 2, 3, 4, 5, 6. Do they just tell us this? No. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, that's got to be roughly 21. I'm not actually going to count them. Probably should have. I was 2/3 of the way there. Okay, so we have the count of boxes, and now I need to make an array to have a list of boxes. Not allocate, this isn't Fortran. So boxes is going to be box positions. It's going to be 2 by NB. And then we're going to scan. We're going to have a double loop. And then if chars x, y equals left bracket, we're just going to keep track of the left bracket positions and then assume that there's always a matching right bracket to the right of it, because you can never move them out of that configuration. So that should work. And I need to increment I and initialize I. Okay, there's my list of box coordinates. Now, I also want to build up a list of how boxes are constrained. Oh, how do I initialize this? I think I have to make multiple passes. So box constraints. So box I. So it's going to be a Boolean array. And it's number of directions, not number of dimensions, but 4 number of directions. Because you could be constrained in the right, but not to the left. Or up, but not down. So we need 4, we don't need 2. So it's 4 by number of boxes. And then we're going to iterate until we hit a fixed point, because we're going to figure out if a box is constrained by a wall, but then we need to eventually figure out if a box is constrained by other boxes. So just to initialize this thing, I need to do like an iterative approach. Okay, so let's get the box coordinates. So we're iterating through the boxes, and then we want to check if there's a wall in each direction. I think I have to actually code this loop multiple times. No, I don't. Okay. Okay, box X and box Y. Now we have to iterate through the directions. Check if there's a wall there or another box which is constrained in that direction. And we need to check the position. X and Y. Now at X, Y, and 1 to the right, we're going to have to check 2 locations because each box is 2 units wide. We're going to check if there's a wall there or a box constrained in that direction. So BC, direction that, and then box I. That's going to be if there's a wall, or if there's a box there. How am I going to move the boxes? I think I still need a queue. Because I can keep track of the constraints like this. Okay, yeah, maybe scrap this idea. I should set like a cutoff, like 2 a.m. or something. Like if I don't have it fixed by then, just stop working. Yeah, let's scrap that. Right, what's my status here? Okay, it's free of syntax errors. Okay, forget the constraints idea. Because that helps me figure out if I can move a box or not, but then when it comes to updating positions, I still have an iterative problem where I need a stack. So we're going to have a stack of positions to process. It's going to be 2 by, worst case scenario, nx times ny. No, I don't think I need this either. It might just be like the number of boxes times 2. But why not over allocate nx times ny? And then we're going to have a stack pointer, but I want to reset that to 0 on each instruction iteration. So that is not going to work. Let's comment out all of that. Probably end up having to print debug this. Okay, some of these braces are unnecessary. Okay. So we move the robot. Then what? Now we're going to push that position onto a stack. So we're going to have a stack pointer. It initializes to 0. Let me push that position onto the stack. So stack is going to be x, y, and then we increment the stack pointer. Now, we're going to iterate until this stack is empty. It's kind of like the stack-based algorithm that we used to search the height map a few days ago, and then there was another search problem on a 2D grid. I can't remember what it was. Oh, flood filling the garden plots or the vegetable gardens, whatever that was. But now we have a stack of positions. And then what do we do with it? Do we want to push this if there's not a box there? Or do I want to build that logic into my loop? So we're going to iterate until the stack is empty. And then we're going to pop something off the stack. So we're going to decrement the stack pointer first, and then X. No, X is the robot position, so I don't really want to touch that. Just a position P. So PX is stack. I could make it a vector here. Okay. Then what? So if the character at that position is a free space, we don't have to do anything. I think down here I was always checking cares not as my condition. So I think I want to do that here too, because I don't want to have like a half updated grid that I'm looking at. If that's a free space, we can just continue. If it's a wall, we're going to have an unresolvable collision. And then I should be able to break. Out of this loop. So if we have a wall, we're fucked. Pretty sure I didn't do anything with this Boolean. I set it, and then I reset it. Yeah. And this is just going to take care of everything beautifully. So as we're moving boxes within the stack, we're updating the characters. So if we need to reset everything, we just reset this whole grid, and that resets every box that we moved. And then the only metadata is the robot position, which is not included in the cares array. Maybe I shouldn't have done it like that, but I think it should work. Okay, so those are the easy cases. And then if we find a box, we're going to push that onto the stack too to move that. And then we have to move the previous character. So do I need a stack of previous characters? I guess so. Because it might be a left bracket or a right bracket. Or we could just assume that it's moved from the direction that we're moving. Yeah, so we continue for dot, we break for hash, and then I think those are the only other conditions we have left, but because we used continue and break, we don't really need to nest it with another condition. It's just the only way we can get there. So dot, hash, or brackets. So let me copy and paste that just so I can see it, even though we're going to have to completely change that logic. Okay, so we need to get the previous character, and to get that we need to get the previous position, which is px py minus the direction that we're moving. So px minus dirs 0 id. You have id for the direction index. Yep. And similar for y. Okay. When we didn't have a stack, this was just tied to the iteration, so I could track it with care not, but because we have a stack now, I have to calculate it by like reversing the direction. It's not hard, but it's different from part 1. Okay, and then we can get care not. Do I already have this declared? No. That not set anywhere? Guess not. So we only need to know the previous position so that we can get this thing. Yeah. And now the current position is going to get this character. So instead of doing that, well, actually, yeah, we're going to do exactly this now that we have that variable set up. That. Then where are we moving it to? Plus, I hope this isn't off by 1. I'm a little bit confused at this point. But we have a position, we have what's getting moved into that position, and then we have where this position is getting moved to. Now, we can't move it into a wall. Chars pxn pyn not equal wall, then we can update it. What did I do in part 1? I feel like this was not correct. Because was this already commented out? I don't think so. How the fuck did this work? So first we move the robot. And that must have been a free space. But it might be moving into a box. So this position might be a box. I feel like one of these is redundant, but I'm not sure which one. Okay, so we move something. And then what? And how am I handling the double box width? I think I have to look left and look right. I have to, I'm gonna have to check which of these characters I'm on. Oh, no, I just need to push two things. I don't need to move two things here. I just need to push two things onto a stack. So, how do we push something like this, but those aren't the coordinates that I want? I think I want px and py. Push the robot's new position. So we just popped these off the stack. Okay, so I think I do want to calculate this. It's not x and y. It's pxn, pyn, the next position. Okay. Do I have to push three things? Because this, we moved this box. We moved half of this box. So we're going to have to move the other half of the box and then push the current position of this box and push. No, I think I only have to push one thing, but it's going to be like the previous position of the other half. I think. Not totally sure about that. And it depends which box half we're on. So if char 0 is that, could just be else probably, but I'm going to want to do that explicitly. Make it else if, not just else. Because I don't really know if this is right. So let's be judicious in the logic or over specific. I don't think this is right. So we just popped these off the stack. OX is definitely, that's definitely not right. Okay, let me focus on this first. So I think it's px plus 1, right? If we have the left half, then the right half is going to be plus 1 to the right, but then just py. And then if we have the right half, it's going to be px minus 1, because the other half is to the left. So I think that stack logic is correct. But then I think this stuff is wrong. So I don't think we need the previous position. I think we just want px and py, because px, py is the previous position, and then pxn is the next position. Maybe I have these both shifted off by 1, so maybe I want the previous and current instead of the current and the next. Okay, that might be it. This probably has syntax errors. And even worse, it probably has logical errors, which will run but not give me the right answer. But I think I'm ready to test it. All right, let's see what this does. That crashes. On the first move. Okay, thank God. I'm editing part 2. All right, let's print the instruction. Like, did we get through one move at least? No, we crashed on the first move. Okay, what does this expanded grid look like? That's how it finishes. How do we start? Okay, so we move to the left. Then what are we popping and pushing off this stack? It does a whole lot. Oh, God damn it. It gets into an infinite loop with one half of the box and the other half of the box. So I don't think I want to handle that using the stack. I just want to move them both at once. So instead of pushing those to the stack, I want to move it immediately. Move paired box half position. Okay. So we can set the current position, but then what gets filled in from where it was? That's the tricky part. So actually, it's easy. It's just whatever was to the right of that is going to be here. So chars pxn plus 1 pyn is going to be chars not px plus 1 py. I think it's that simple. And then this one is just going to be minus instead of plus. Let's see how that works. But do I need to push something? No, because I tried pushing something and that was an infinite loop. Something happened. God damn it. No, I just like multiplied my number of boxes. So we move left first. That part should be easy. Let's debug the first step. So we had an at here, and then we moved them, but we didn't really fill this in with the previous position. I think I have to clean up some of this junk, but I'm scared to delete it, so I'm actually going to back this up. The 0. Okay. So what am I doing with these chars? At least we didn't go into an infinite loop. Nine. 0, 1, 2, 3, 4. 0, 1, 2, 3, 4, 5, 6, 7. So we take the robot and we move it to 7, 4. That's right there. And then we end up processing these 3 positions. So that's correct. We're just not updating things correctly. When we move the robot, we don't have to update any characters. And I think I want to see if I'm hitting the continue at least. Well, I just overwrote that backup. I could like undo in my text editor, but I don't think it matters. Okay, so we move the robot here. So we have a right bracket, a left bracket, and then a dot. I think you don't always want to do this. I think I have a bug specific to moving to the left and right. If not, so if we're moving left, and that's the last character. And this is the current character. And then not that. Then we can move. Or if we flip all of these directions, or if we're moving to the right, then we have this bracket and then the other bracket. If it's not either of those cases, then we push. Otherwise, if it's this case, then we're going to move it automatically here. And same with this case. Otherwise, we push it onto the stack. That's still wrong. Pushing, pushing. So that didn't seem to work. Care. Is that not wrong? Left, right, left. Left, right, left. But not that. I think I want and instead of or. Still wrong. but it's not pushing now. Right here it said pushing. Now it's not doing that. But we still didn't update things correctly. Yeah, I think there's like a left-right condition and an up-down condition. So if we're going left or right, I think we can always push. But then we don't want to do this. So do I just want to wrap this here? No. I'm tired of sitting down. I might have to give up on this tonight. Instruction left. Only doing one iteration. I think inside my stack. I want an extra new line print delimiter. Okay, we're moving left. PXY 7-4, currently on a right bracket. We're moving it to where a left bracket is. So we push that. I think I wanted the previous and the current positions, not current and next. Something about this was on the right track. How's that? Wrong in a different way. What am I pushing? I need a print grid function. Because I need to do it on each stack iteration, not just once at the end. And then I'm tired of looking at this with all the comma delimiters. And I made a helper function yesterday that will help with this. Yeah, so this is going to go into utils. Okay. For y, you don't have access to nx and ny here, so chars 1, not 0. We're going to print line cat strings chars everything in that row. How's that look? That doesn't work. I think I missed a parenthesis. Well, it doesn't return a value, so I feel like return should be optional. So that's more readable. Fortunately, still wrong. But now I can debug more easily. Okay, so at each stack iteration, I want to do this. So essentially we just deleted this bracket. Is that what I want? Oh. So in these cases, I think I still have to fill in the previous character. So do I just move it up there? I'm so tired. Didn't actually set anything there. Oh my god. Okay. We moved one. Can we do the second instruction? So I. What is the second instruction? I don't need to go to the web for that. Next one is down, so none of the boxes should move on the second instruction. Let's see what all of them do. That looks wrong. You shouldn't end up with unpaired boxes. Okay. So when does that bullshit start? It's probably like some of this logic that's messed up. So we've got some debugging to do. Is that visible? It's a little close. I don't... So this is like the final output of one instruction iteration. So like, of course these ones should look corrupt, but this one should look okay. Then we move down. And I'm not showing the at, so that kind of makes things difficult. So I think we're here. Then we move down again, so we should be there. We move right, so it should push those two boxes. That didn't work. Oh no, these are the stack cares. So I think that worked. These are half lined up now. Before, this box was not vertically aligned with that diagonally catty-cornered one. So that seems okay. It must be one of the up or down moves that's wrong. Okay, then we move up. So we're here, we should end up there. Then we move left, should end up there. And there's no stack iteration here because we're not even close to running into any boxes. Then we move down, so we should end up here. Again, no stack iteration. And then what? Up again? Come on, man. So we should end up there, then right. I think I need to work through the smaller example because I'm getting lost. Right should take us there. Down should take us here. Then right should finally move these boxes again. So we get some stack iterations. It says stack cares instead of nothing. So I think we're here. Right, yeah, that's the one that was getting updated. Then what? We move up. We move down. And we move down again. This is way too time consuming. Then back up. We're just like doing and redoing without really changing any box positions. Then back down. Come on, man. Finally right. That should move these boxes. So we get some stack iterations. And those boxes have moved. I'm tired. Then down. Down should be blocked. So we try to move down, we start updating the stack, but then we reset everything, so we get back to where we were. Then left. I really need to be printing the at character. Then right. Down should do nothing again. Did nothing. Then finally up. This should be interesting. So we should have two boxes that should both move up. And they have space to move up. So this is probably where the bug is, because we haven't seen this case yet. So that's wrong. Which iteration is this? I'm not printing the iteration number. So that's going to be annoying to find. So if I can search for that, I have to escape. I think I have to escape the square brackets. This is the third occurrence of that already. Oh, we got really close, actually. We moved everything up, but we never reset that one. So I think I see what the issue is. So in this case, I do want to push multiple things to the stack. So instruction equals up or down, and what? Care not? I want care not. Oh, let's nest this. So if we're on the left half, then we want to push x plus 1 to the stack. If we're on the right half, we want to push minus 1 to the stack. Okay. So this is where things are corrupted. So I'm at this point in the logs. I haven't changed any logging. So hopefully this should just become correct when I rerun this. Still looks wrong as the final answer on the left there. But let's see what happens on the right. Maybe I want to push these instead. Those both seem wrong. Oh, these conditions are wrong. I don't want to compare the instruction. I want to compare care not. Still not. That still doesn't look right. So maybe I have to get rid of that N. That crashes. What did I do in part 1? It's some weird logic. Like, why did I do this? Where the hell did I just jump to in the log? Okay. It crashed before it finished that stack iteration. It's an infinite loop again. Maybe I never want to do this. Still crashes. Got through quite a few more iterations. Okay, there's an easy way to avoid infinite loops. We just need like a visited array. And then don't repush things that we've already visited. This is a usual component of my stack search algorithms. I don't know why I didn't think of this until now. So we pop from the stack. And if we've already visited, then we skip everything else. Well, that fixed the infinite loop. But the logic is still not right. So I'm jumping back and forth between two instruction iterations. So we moved this box and this box up, but I still didn't delete that. PX not, PY not. Cares PX plus 1. Cares not PX plus 1. PY not. We're moving up or down, so I don't need to do PX not. Here's the thing, if we push it onto the stack here, then it should automatically update the characters up here when we pop that back off the stack again. Is this logic okay? before I start messing with the log, let me figure out which iteration I'm on. Okay, so instructions 21. 21, but not 210. If I scroll down from there, that's where it gets corrupt. Okay. Well, it's kind of backwards here, because if care not is left bracket, then the pair is going to be a right bracket. Okay, so that's a right bracket. But this is wrong. Should it be that? Still looks wrong. Oh my god, I'm so tired. It's after 2 a.m. I think I have to call it on this. PY not. Don't think I tried that. Still wrong. I don't fucking know, man. That? Is that worse? I'm tired of sitting in this chair. I've been at this for too long. I feel like N was correct there. I think I already tried this. I don't know which combinations of things I've tried. That's when you're in a death spiral of debugging. Okay, this is at least wrong in the way that it used to be. I feel like I have the logic here. It's just not right. Pebcac. I think that's my problem. What if I push both? What if I push all three? No, because I'm setting it to the previous character. But in this case, I don't know. Yeah, like that should work. What if I just forcibly clear it? Right, because if you run into one half of the box and you move the other half, it must leave a free space. Hey, MMC, I think I have to give up here. It's way too late for me. Are you an advent of coder? What if I just forcibly fill that with a free space? That's not right. If it's that. So I think it's that. Has to be that. This step is correct now. But I only did that for half. So let's do this too. Too many cases. I had all my directions like encoded so that I could avoid case analysis, but now I have like 4 different cases for every different direction. A lot of it's commented out, so I think maybe I have my left-right cases nicely consolidated, but the up-down conditions are tough. Are you on part 1 or part 2? Or are you on a previous day? Yeah, the final answer is still wrong. So I don't know. I got this step correct. So I have like the first 21 steps. I have the first 23 steps correct. So when does this start looking funny? When do I have a box and a dot? Oh, well, these are stack characters. So maybe I should not print that at all. Because of course those are going to be invalid. 658, line 658, or the other combination, 650. Okay, so that's the same time step. So up until iteration 32, this looks correct. But then 33, things go wrong. So moving up, I have no idea. I'm at 5, 7 apparently, but I'm not marking that in my grid. So 5, 7 would be 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, 6, 7. I think we were here and then we move up. So then this gets moved up, but it's the other half of that box doesn't move. I thought I was handling that case. Oh, maybe I need to uncomment this now. It's not that. Am I? So maybe I'm not pushing the right thing. $674. Oh no, this is corrupted even earlier now, so that's not good. Maybe I don't want this. I really think I have to give up. Yeah, I'm gonna be here all night if I keep trying to get this. So I think I've got to call it. It seems like a solvable problem. I don't know what I'm doing wrong. It's so tempting to just keep looking at it. So whatever I did made it worse. It was kind of okay. I feel like that's the one that I should be pushing. Okay, so that made that one better. And I still fail at instruction 32. So how? It's the same case. Here I moved up, I pushed on a left bracket, and then it moved the corresponding right bracket. And now I'm moving up, I'm pushing on a right bracket, and it should also move the corresponding left bracket. So, like, how did I fuck that up? It's the difference between this and this. X minus 1, X minus 1. Say pushing pair. Never says pushing pair. So we have a right bracket. This is instruction 32. Up or down. Care 0 not the thing that I should be checking? Okay, yeah, I think I have like an off by 1 on care 0. I don't think that's what I should be checking. Maybe just care. Because that's what was different about the first case. It had another pair of brackets directly above it. So if I was off by 1, still wrong. Now it at least pushes the pair. No, I'm fucking up an earlier case now. See, I fix one thing and then I find out that something else was already broken earlier. Instructions 20, instructions 21. So this is where I was messing up earlier. Okay, so this guy disappeared somehow. I do feel like this is unnecessary. So I fixed that, but now this is fucked up. What the fuck? Because that is below it. Jesus Christ. Shut up. Is that not what this is? Pushing pair right bracket. So is this in the wrong place? I had it down here before. Everything, all of my brackets disappeared. Because it certainly feels like this should be unnecessary. I don't know, man. I really have to give up here. Okay, that's not terrible, at least. It's wrong. Like, it's kind of close. Oh, Julia? I've played with it for about 5 minutes. It's pretty cool. My issue is that it made the mistake that MATLAB made, and maybe there's a good argument that it should be like this, but they have row vectors and column vectors. I think that's too much. I think there should just be one kind of vector. It's cool because then you can do a dot product by like multiplying a transpose, by like multiplying a row vector by a column vector, or do you swap those in the left-right order? But I think you should just have a function for dot products, or an operator. But I think a vector is inherently a one-dimensional thing, and it shouldn't distinguish whether it's a row or a column. MATLAB is like that too. Fortran is not like that. So I like array languages that are like Fortran. I think it's probably a good first language. Okay, what if I move this? Is everything broken? How broken is everything? Okay, I think I like this one. It's kind of close. What if I move this down after the breaks and continues and push something different? If I push that. And don't do this. No, that looks worse. I really have to give up here. No, a little bit of C. I think C is also a good language. I think it's kind of hard to learn, as a first language. I don't know. Maybe some people would say that you should learn a hard language first and then everything else feels super easy. I don't think they have any value in industry, but I think it's a good thing to learn. I really like using Project Euler to like learn a language. So I think it's useful for learning, and it doesn't matter that there's no industrial application. I'm just gonna undo a bunch of stuff. I'm tired. It's 2:30. I think I have to end this stream. But I want to get this code close to working. So I think this is a state where it was close to working. I actually had this whole step working before, and then what else did I change? I don't remember. Like I commented that or something. Yeah, this is a mess. I don't know what my logical flaw is. I thought it was really close. I think I understand the problem, but yeah, I'm not going to get it tonight. It's 2:30 a.m. I'm tired of sitting in this chair. Oh, like it's hard to move. All right, there we go. Part 2. Do I still have the right answer for part 1 at least? 1092. That's not the real input. One 4416. Okay, so that's part 1. I can't figure out part 2 tonight. Oh, I got a stack trace. All right. That's going to be it for tonight. I'm way too tired. Thanks to everybody who tuned in. I'll catch you next time. Bye.